Welcome to section 6.7, similar figures. Excuse me, this is very similar to section 6.6, except for that we don't have to create any drawings here, that they're pretty much all created for us. We've already used scales and scale factors to make scale drawings or scale models of things, and now we're going to use, moved to now. Now we're going to find missing measures of similar figures and use scale factors to prove problems. So we're really doing the same stuff we've done now with just a different drawing. Excuse me. So the first thing to talk about is what similar figures are. The book defines them as figures that have the same shape but not necessarily the same size. I prefer just to say, you know what, they're proportional. Okay. There's a little more to it than that, but that's the basic idea, proportional figures. Figure ABCD is similar to figure EFGH, and then symbols, we use a little thing here, a little tilde like you did in Spanish class, and that means similar to. So ABCD is similar to EFGH. Now there is one thing that is important here. The order of letters is important because we're going to talk about corresponding parts. Oops, and A corresponds to E, B corresponds to F, C corresponds to G, and D corresponds to H. Hey, I did okay in those last couple. Wow, that was a little ugly. But the order does matter in the statement. It tells you what corresponds to what. So what that means for us is, like I said down here, A corresponds to E, C corresponds to G. They're the figures A and E are both in the same spot. C and G are both in the same spot. Also works for the sides. AB is a side from A to B. B to C is a side, C to D, and A to D is a side. All those are sides because they connect 2 points. AB corresponds to the EF because they're both in the same position, and AB is the first 2 letters and the EF are the first 2 letters. So corresponding parts are sides and angles on the 2 figures that are in the same place, basically. So here's the book's definition, or at least kind of a concept part of it. Similar figures. If 2 figures are similar, then it means 1, the corresponding angles are congruent. Oh, sorry, a little late here. Corresponding angles are congruent, and they have the same measure. And the corresponding sides are proportional in opposite corresponding angles. So that's one of the things I left out up here, is that these corresponding angle pairs, A to E, B to F, C to G, D to H, they're actually the same measure. That's what congruent means. The sides are proportional in their length. Here's the first example, okay, and really what this consists of is you being able to kind of match things up. So for instance, if I look at this, I've got segment MP that I know is 3. M is a double mark, P is a single mark for the angles. If I look down here, that corresponds directly with side AD, which is double mark to single mark for the angles, A to D, M to P. PO is down here, single to triple. D is down here, single. DC is down here, single to triple, and that's the proportion I'm going to set up. Okay, 3 over 12 equals x over 33. Okay, because 3 and 12 corresponded, x and 33 corresponded, and now I can just cross multiply. 12x equals to 99, divided by 12. That ends up being 33 over 4, which is 8 1/4, or 8.25, and they were in inches, so 8.25 inches. Okay, so again, it's just setting up this proportion and solving again. The key is knowing what goes to what. Okay, so here's an example for you to solve then on your own in the video. They'll come to the side, so make sure if you need to, you can always go back and relook at it. But we're going to figure out side lengths here. We're trying to find x. So is it 1.56, 10, or 16.7? And using this part here to do that. Okay. So now on this on to drawing. Nested boxes. So next, nested boxes are a series of boxes that fit inside each other. So something like this. So here are nested boxes. You might have seen, I've got, like, my kids actually have a couple toys like this where they're a little old for this now, but where they kind of all just stacked inside of each other and they fit perfectly. Or you might have seen, where you can keep opening it up and the boxes keep stacking up like that. So we're talking about nested boxes. So the faces of the boxes are similar rectangles. A face in a larger box is a length of 24 and a width of 13.5. If the width in the face of a smaller box is 9 centimeters, what's the length of the smaller box? So the key to this is realizing we're going to do width to width equals length to length. And we actually have larger. So width for the larger, length for the larger, width for the smaller, length for the smaller. So I know I'm going to have to jump off screen here for you to take a look at this. But here we go. So that's sloppy. I'm going to do this bigger. So width of the larger to width of the smaller equals length of the larger to length of the smaller. So those are what you've got for your lengths, your sizes. So let's see, width. That tells us here that the width of the larger is 13.5 centimeters. The width in the smaller one is 9 centimeters. The length of the larger one is 24 centimeters. We don't know the length of the smaller box. That's what we're looking for. So this is the proportion we've got set up. I have a feeling I'm going to want my calculator for this, just to make the calculations a little easier, but we'll see. We'll hold off. So I know I'm going to cross multiply. Okay. 9 times 24 equals 13.5 times x. This gives us 216 equals 13.5x, and I have to divide by, whoops, I'm off screen here, 13.5, and I probably could try to fake that by hand or my head, but I'm not going to. So let's just see. Make sure I did my other math right. For some reason I feel like that's wrong. 9 times 24. Nope, that's good. Divided by 13.5. Oh, 16 works perfectly. It's weird. So 16 equals x. So it's going to be 16, and what are the units on this? I think it's centimeters. Let me go back to it. Yeah, 16 centimeters. Okay. So that's the length of the smaller box, 16 centimeters. Okay. All right, so basically that's the way the problems work out. Just setting up proportions still, but now they'll have some drawings along with them. So you got a homework problem to knock out, and we'll go over some more of these in class. Great, thanks.